Ultrasonic distance meter. This project is designed to develop a distance measurement system using ultrasonic sensor and Arduino. We know that human audible frequency ranges 20 Hz to 20 kHz. We can utilize these frequency range waves through ultrasonic sensor HCSR04 to make a distance measurement system. This distance measurement system can be widely used as a range meter and as a proximity detector in industries. This sensor works on the principle of Doppler effect. This sensor measures the time duration between the transmitted sound wave and the received sound wave reflected from the obstacle. We know that speed of sound is 331 meter per second. This time and speed is used to measure the distance between sensor and the obstacle. This method of measurement is an efficient way to measure small distances precisely. Here is the connection diagram of this project. 16x2 LCD display has two lines. Each line can display 16 characters. This display has 16 pins. First pin is ground, second is VCC, then contrast, RS, RW, enable, D0, D1, D2, D3, D4, D5, D6, D7, VCC, and ground. Pin 1 and 2 provide the supply for its internal circuitry, and pin 15 and 16 provides the supply for its backlight. We have connected pin number 1, 5, and 16 with the ground pin of Arduino, and pin number 2 and 15 with the 5-volt. Pin number 4 of LCD is connected to the pin number 12, and pin number 6 of LCD is connected to the pin number 11 of Arduino. Pin 7, 8, 9, and 10 are not used. Pin 11, 12, 13, and 14 of LCD display are connected to the pin 5, 4, 3 and 2 of Arduino respectively. Ultrasonic sensor has 4 pins: VCC, ground, trigger, and echo. Echo pin is connected with pin number 10 of Arduino. Trigger pin is connected with pin number 9. VCC pin is connected with the 5-volt pin, and ground pin is connected with the ground pin of Arduino. This is the code of our project. To control the LCD display, we will first include its library in the program. To include the library, we will write in the first line #include liquid crystal.h. Then we will declare the name of the used pins in the sequence of RS, enable, D4, D5, D6, and D7. We have connected trigger pin at pin number 9 and echo pin at pin number 10 of Arduino. Now we will declare two variables, duration and distance. Void setup is a function in which we have initialized the LCD by using this function lcd.begin 16,2. It means we are using 16 column and 2 rows of the LCD display. Pin number 9 of Arduino is connected with the trigger pin of sensor, so we will make it an output pin. Pin number 10 of Arduino is connected with the echo pin of sensor, so we will make it an input pin. Void loop. This function will run over and over again, so whatever we write inside it will repeat forever. To transmit a sound wave from ultrasonic sensor, we have to give a 10 microsecond high to low pulse at its trigger pin. So we will first give a low signal at trigger pin, then we will give a high signal at trigger pin, then we will wait for 10 microsecond, then we will give a low signal. This variable, duration, will store the time duration after which sensor receives the reflected waves. This variable, distance, will measure and store the distance between sensor and the obstacle. lcd.clear. This function is used to clear the LCD screen. lcd.printDistance will display the reading of ultrasonic sensor on LCD display in centimeters. Delay 100. This function will generate 100 milliseconds of delay. Now, we will write a code on this software. After writing the code, we will save our project. Now we will compile our code. For doing this, press this check button. If there is any error in the code, or the code is incorrect, it can be seen on the message screen below. If the code is correct, we can upload it to our Arduino hardware board. For this, We will first connect the Arduino board to the USB port of our computer. Now we will go to the Tools menu and select Arduino Uno. Then, we will go to the port option and select the port at which Arduino is connected. Now, to transfer this code to our hardware, we will press this arrow button. Now we will assemble our hardware. We will take 3 wires, 1 red and 2 black. We will use these wires later. Now we will solder a black wire at hole number 1 and red wire at hole number 2 of LCD display. Now we will solder a white wire at hole number 4 and brown wire at hole number 6 of LCD display. Now we will solder orange, yellow, green, and blue wires at pin number 11, 12, 13, and 14 of LCD display. Now connect hole number 16 with hole number 1 using a black wire, and hole number 15 with hole number 2 of LCD display using a red wire. Now connect hole number 5 with hole number 1 of LCD display using a black wire. Now connect hole number 3 with hole number 1 of LCD display through a 1 kilo ohm resistor. Now we will connect the LCD display with our Arduino hardware board. Connect the red wire with 5-volt pin and black wire with the ground pin. Now connect white, brown, orange, yellow, green, and blue wires with pin number 12, 11, 5, 4, 3, and 2 of Arduino respectively. Connect red, black, yellow, and green wires at VCC, ground, trigger and echo pins of the sensor respectively. Connect the red wire of sensor with the 5-volt pin, black wire with the ground pin, yellow wire with pin number 9, and green wire at pin number 10 of Arduino. Now we will power up our circuit and test its functionality. We can see that our sensor is measuring the distance accurately, with 5 to 10% of fluctuations. I hope you enjoyed the video and learned something from it. For any help in your project, or to clear your doubts, you can contact us on our student care number 7007957715. To purchase the items used in the video, you can visit our website www.erolltech.com. You can order us on our WhatsApp number also. Thank you so much.